Okay, so this is Chapter 1, Section 2, Basics of Functions. At the top of the page here, we have a few definitions that hopefully you've seen before, but if not, please make sure that you review them here. A relation is just any set of orders, pairs, or any relationship between two variables. Our domain is typically our x values, it's the input, and range is our output, typically the y values. And a function is a special type of relation where each member of the domain matches with only one member of the range. In other words, no two ordered pairs have the same x value but different y values. Now, typically we refer to x as the independent variable. Again, it's the input. And then the dependent variable, it depends on x. Our y value is dependent on whatever x is. That's our output variable. F of x is function notation. You've seen this before and we'll be using it. And let's look at some examples here. So our first example says, state the domain and range of the following and determine if it's a function or not. So first off, looking at our x values, we know that we see no repeats in the x values, so we know that it's a function. And then we need to state what our domain and our range is. Well, our domain is whatever our x values are here. So 1, 2, 3, and 4. And our range is our y values here. In this case, that would be 6, 6, 8, and 9. So 6, 8, 9. We don't need to list the repeats. Let's go ahead and look at the next one. And right off the bat, I know that it is not a function because this same x value here matches with two different y values, and that makes it not a function. Okay. We still need to state the domain and the range. So our domain here is 6, 8, and 9. And then our range is 1, 2, 3, and 4. And these two sets actually have a special relationship, but we'll talk more about that later. Now if we want to determine if an equation is a function, the first thing we want to do is get y by itself. So looking at these two functions here, determining if they are functions or not, we want to get y by itself. So we subtract 2x from both sides here, and we get y is equal to negative 2x plus 6. And then we just want to kind of ask ourselves, for every x value that I plug in here, am I going to get multiple y values? And for this first example, the answer is no. There's no x value I can plug in here and get multiple y values. For example, if I plug in 1, then I have negative 2 times 1 is negative 2, plus 6 is 4. It's not like I'm getting 4 and negative 4. Now looking at, so let's just state real quick that is function. And then let's look at the next one. We want to get y by itself, so I would subtract x squared onto the other side. And y is still not by itself. I want to square root that. And when we take the square root of both sides, we need to put plus or minus here. And that's my first hint or instinct that maybe this is not a function. Now, if I plug in a single x value, let's say I plug in 0. Well, 9 minus 0 is going to be 9. Square root of 9 is 3. And plugging in a single x value, 0, gave me positive 3 and negative 3. And that's my hint or my suggestion, or really my evidence, that this is not a function. So that plus or minus there is a big hint to us here. Now if this was a cube root, let's say I was taking the cube root, well we don't need plus or minus there. We can take the cube root of something negative. So again, even powers and odd powers work a little bit differently. Now looking at the bottom of the page, we have the vertical line test. Hopefully that's something that you've learned before in Algebra 2 and Algebra 1. And the vertical line tells us that if I draw a vertical line and it hits my graph at more than one point, then this is not a function. So looking at these examples, this first one here, none of these vertical lines hit more than once, so this is a function. And this one, it's a little bit hard to tell, so I'm going to help this picture a little bit here. This is the y-axis, and right here we have the x-axis. And this is my function right here, this vertical line. Now, all of these vertical lines are all fine, but this vertical line that I'm hitting here, it's obviously hitting more than once. In fact, it's hitting at every point. So this is not a function. And then this last one, even though this line works, this line works, this line works, and this one works, any line hitting this ellipse here is going to hit more than once. Even though this line right here might work, every single line has to work. So this is not a function. And I'm going to go ahead and flip to the next page here. And it says, state the domain and the range for g of x. And we're given a picture here. Because this picture isn't perfect here, I've kind of made some notes for you here. It says, assume that there's an open hole at g of 4. Okay, so there's an open hole here. And a closed hole at g of negative 4. So we have a closed dot here. Let me zoom out a little bit for us. We want to state the domain and the range. So again, our domain is our x values here, and our x value at negative 4 is defined here. That's our smallest x value, and it goes all the way to positive 4. But the difference here is that it's not defined at positive 4, so we'll use a parenthesis. And our range here goes from negative 8 to positive 8. However, it's defined at negative 8, but at positive 8, it's not defined. We've got an open dot, so we'll use parentheses. And that's our domain and range for that function. This is a concept that's going to be really important in calculus, so this is something that you want to nail down very, very well. And that is the end of section 2 for chapter 1.